Now we will start with the next practical, that is a practical number 14. In the practical number 14 we have a find the smallest number from an array. Find the smallest number from an array. So the problem statement is that write 8086 assembly language program to find the smallest number from a block of bytes. So in this program, the data stored at location of 8001H onwards, the 800H is containing the size of the block. After executing this program, it will return the smallest number and store it at location of 9000H. Logic is simple. We are taking the first number at the register B to start the job. In each iteration, we are getting the number from memory and storing it into register A. Then if B greater than A, then we simplify update the value of B with A. Otherwise go for the next iteration. Thus we can find the smallest number in a block of byte. So this is the logic for the find out the smallest number. This is the input we are given. Address is 800. On the location of 800 we have a 6. We have a 55. We have a 22 on 2. So we apply the, if the B is greater than, suppose the 55 is greater than 6, then it will be comes to the in that position, first position. 55, 22, 44, 11, 33 and the 66 are the address. So this is the flow chart. We can see this is a flow chart for. First we will start C is equals to block size, HR is equals to address of the first element, and B is a load item from memory. Then C equals to C minus 1. Then HL equals to HL minus 1. HL minus 1, then we will go to the A item of memory address pointed by HL. If B is greater than A is true, then B equals to A equals to A. If B is greater than is a false, then the C equals to C minus 1, then directly go to the Z. If B equals to A, then also directly go to the Z equals to 0. If the Z equals to 0 is matches to the HL value, then it will be again repeat the procedure, and if it is false, then it store the minimum number from B to memory and then it will be end. So this is the flowchart for the smallest number. So now we will see the program. In the program, we write out the LXI H, 800H point to get array size. Move C, M get the size of array. Increment H point to the actual array. Move B, M load the first number into B. DCRC decrease the C. INX H point to next location. Move A, M get the next number. So this is a loop. And this is the hexadecimal value, how we can move from the 0 to 15 up to the 16. Then move A, M, get the next number from memory to ACC. Then compare B, compare ACC and B. Then jump, skip. If B less than equals to A, then skip. If B is greater than equals to A, then it will be again go to the, for the checking. Move B, A. If CY is 1, update B. DCR C, decrease C. JNZ loop, when count is not 0, go to loop. If count is not 0, LXI H, 900H point to destination address. Move M, B, store the minimum number. HLT, terminate the program. So these are the mnemonics. We can say this is a program and this is a command. So finally we get the output as the smallest number as a 11. So the smallest number is from these things, from 11, 22. This is the only the 6 data. Let's say 1, 2, 3, 4, 5, 6. So 6 is the data and address from start from 800. So from this 11, 22, the smallest number is 11. So you will get a output as a 11 number. Okay. So this is the table. We can see this is the address, then the hex codes, then the labels, then the mnemonics, that is a program, and the comments. You can see this. I will give you 5 seconds to see you. You can solve this program. We tell you how to execute. Next is your practical number 15. In previous we see the smallest number. Now we will see the in the practical number 15 we will see the find the largest number from an array. So for the finding the largest number, the program is write 8086 assembly language program to find the largest number in a given array which start the memory offset 501 The size of the series is stored at memory offset 500. Store the largest number at memory offset 600. At the first, we are taking the size of the array from memory offset 500. Then using that size, we are initializing the counter to read and check all the numbers. We are taking the first number into AL, then check each number and compare it with AL. If the AL is smaller than array element, then update AL with the carrier element. Otherwise, skip that element and point to the next element. Thus, the largest number is found. So, this is the logic behind the largest number. You will read this and understand it properly, how it can be done. So, you can see the 500 is your what? It is your memory size. 500 is your memory size and total data are the 6. So out of 6 data, so this is a 1, 2, this is, you don't have to consider this. This is the size and this is the data. So from 1, 2, 3, 4, 5, 6. So total we have a 1 to 6 data. From this data you have to find the largest number. So first you have to start. CL is the array size, CH is the 00H, SI equals to first element address of the array. AL is the element from SI. CL is equals to CL minus 1 and SI equals to SI plus 1. Then if the CL is greater than 0 is a true, then you will get to the AL less than memory element of SI. If it is false, then you store this element into the LA and it will be end. If it is not true, then you will go to the AL equals to memory element of SI. If this condition is true, then you will directly go to the CL again and then will come up with the end. So this is the flow diagram for the largest number. Next you can see the program. Now move SI comma 500 point 500 using the SI register. Move CL comma SL, then load the CL register, then clear the CL register using the CH. Increase SI to point next location. Move AL comma SI, load data from array to AL. Decrement CL, decrease CL by 1. INC CI, point to next location. Compare AL SI, compare AL and the next byte. JNC skip means you have C equals to 0, then you will be jump to a skip. If move AL comma SI, otherwise take the memory element into AL, skip. Then INC SI, point to the next location. Loop L1, go to the loop until CL is not 0. Move 600 comma AL, store AL into memory, and last is your terminate the program. So this is the program for the largest number. It is a little same like your smallest number and we have a largest number. For the smallest number we have to arrange the program in ascending order. For largest we have to program for the descending order. This logic you can use. Arrange a program in ascending order, arrange a program in a descending order for the larger element. So on the position of the first, which number is came, this is your largest number. So for the ascending order, the position of the 0th, you will get a smallest number. So from this, the smallest number is CF. So you will get a output as a CF. So this is the on the position of a 600. You can see the position of a 600. You will get a CF. And your final value address is a CF. So when you are changing, so this is the find the largest and smallest number output. Now we will end up with the practical number 14 and 15. Thank you.